Imagine a quiet October evening in 2017 when astronomers scanning the night sky with the Pan-STARRS telescope in Hawaii stumbled upon something extraordinary. It wasn't a typical asteroid, comet, or even a random shooting star. It was a visitor from beyond our solar system, something scientists had only speculated about until that moment. They named it Oumuamua, a Hawaiian term meaning scout or messenger, hinting at the possibility that this strange, elongated object might carry secrets from the distant reaches of the cosmos. The appearance of Oumuamua sparked a wave of excitement, curiosity, and eventually controversy. It wasn't just its interstellar origin that captured imaginations. It was its entirely unprecedented nature. At an estimated speed of 320,000 kilometers per hour, nearly 200,000 miles per hour, this cigar-shaped object hurtled through our solar system at a velocity fast enough to defy the sun's gravitational hold, escaping without being captured in orbit. At first, scientists hesitated to label it anything beyond an interstellar object, as its behavior challenged everything known about such celestial bodies. Moving unpredictably and accelerating mysteriously, Oumuamua didn't exhibit the usual signs of a comet or asteroid as it sped away from the sun. What could it be? What was propelling it forward? And most disturbingly, was it here for a reason beyond natural chance? The search for explanations became urgent. Typically, comets accelerate as they approach a star due to outgassing, where heat from the sun causes frozen gases within the comet to vaporize, creating a tail that propels it forward. This natural thrust leaves a visible trail of gas and dust, a common and expected sight. But Oumuamua showed no such outgassing, no visible trail, no dust, and no other explainable force behind its acceleration. It defied conventional understanding, leaving scientists puzzled and intrigued by the possibilities. With its rapid, unexplained increase in speed, some began to speculate that Oumuamua might not be a natural object after all. Could it be a probe or spacecraft from an alien civilization? This idea gained traction when noted Harvard astrophysicist Avi Loeb proposed that Oumuamua's elongated, cigar-like shape and peculiar acceleration could suggest a type of propulsion unknown to humanity. Loeb suggested that the object could be a light sail, an advanced propulsion technology theoretically capable of harnessing radiation from stars to propel itself through space without the need for fuel. Such technology would be an incredible feat, one that could indicate the presence of an intelligent civilization. While many dismissed this idea as speculative, it sparked heated debate, and the intrigue only grew when Elon Musk, the visionary behind SpaceX, weighed in with his own theories. Musk, known for his bold ideas and ambitious space ventures, suggested that Oumuamua could indeed be the first sign of alien technology, a scout or probe sent to observe our solar system. Musk, like Loeb, speculated that its shape and movement pointed toward intelligent design. It wasn't merely an odd rock tumbling through space. Musk hinted that this visitor might be part of a larger network of probes, potentially sent to study star systems like ours. For Musk, the idea of extraterrestrial technology was no mere science fiction. As someone invested in humanity's exploration of space, he has always entertained the possibility that we are not alone. The suggestion that Oumuamua might be an alien probe, equipped with advanced technology that enabled it to traverse vast interstellar distances, was provocative and unsettling. What if this object wasn't just a random visitor but was, in fact, here to study our solar system? Could we already be under observation by an advanced civilization without even realizing it? If Musk's theory were correct, the implications would be staggering. Oumuamua's presence could mean that we are not the first species to venture beyond our own planet, nor are we the most technologically advanced. The thought that we might be under surveillance, watched by entities with technologies far surpassing our own, is as thrilling as it is terrifying. Beyond its mysterious acceleration, the very shape of Oumuamua was something of an enigma. Most natural objects in space, whether planets, moons, or asteroids, are shaped in roughly spherical or irregular clumps. But Oumuamua was different. Its dimensions were unusual, estimated to be about 800 meters long but only 80 meters wide, resembling a giant cigar. As it spun through space, Oumuamua would brighten and dim every 7.3 hours, a phenomenon that only added to the puzzle. The varying brightness suggested that it was rotating along its shorter axis, a behavior that doesn't match anything we've observed in our solar system. This rotating, elongated object was unlike anything we had ever seen or expected to encounter. Some theorists argued that this shape could be ideal for interstellar travel. An elongated form, especially with the precision and smoothness noted in Oumuamua's appearance, could minimize resistance and withstand the harsh conditions of space. This characteristic led some scientists to consider whether the object might have been artificially constructed. Could it be the product of an alien engineering project designed to travel vast distances or withstand the pressures of cosmic radiation? The object's reflective surface further fueled these theories. Oumuamua's ability to reflect sunlight suggested that it might be coated in a smooth, metallic-like material, unlike anything naturally occurring in our solar system. The idea of alien technology, a spacecraft or probe designed to withstand interstellar travel, gained momentum, and more scientists began to take the idea seriously. As theories about Oumuamua's nature gained traction, the scientific community found itself divided. On one side were those who argued that this was simply a strange but natural object, a cosmic wanderer with unique characteristics. They suggested that its acceleration might be due to an unknown natural process, possibly involving hydrogen ice or some exotic chemical composition that would explain the absence of a visible trail. On the other side were those open to more unconventional explanations like Loeb, Musk, and other proponents of the idea that Oumuamua might be a visitor from an advanced civilization. Loeb argued that if we could not fit Oumuamua into any known category of natural objects, we should be willing to consider the possibility that it was artificial. This line of thinking suggested a need to broaden our scientific approaches to accommodate the unknown. One of the most thrilling aspects of Oumuamua's story is that it may not have been a one-time visitor. Some astronomers have suggested that Oumuamua might return within the next few decades, potentially around the year 2038, when it could pass near the Kuiper Belt or even within the range of our Voyager probes. The possibility of its return raises profound questions. If it comes back, will we be able to observe it more closely? Perhaps even capture images or data that could confirm its nature. The prospect of another encounter has led scientists to prepare for future interstellar visitors. Astronomers are developing more advanced telescopes and detection technologies that could allow us to study similar objects more thoroughly, collecting data that might help us unravel the mysteries left by Oumuamua's initial visit. As we anticipate Oumuamua's possible return, we are left to confront an uncomfortable question. Are we ready for what it could reveal? If this object is indeed an alien probe, it might be equipped with technology far beyond our comprehension. And if it is part of a larger network of interstellar scouts, then Oumuamua could be just one of many such probes silently traversing our galaxy, observing other planets and possibly relaying information back to its creators. The implications of such a discovery would be nothing short of revolutionary. If we are, in fact, being observed by an advanced civilization, we must consider what that means for humanity's future. Are we merely subjects of curiosity, or do these observers have a larger agenda? Do they seek to communicate, or are they simply studying us from afar? These are questions that humanity may have to grapple with sooner than we think. Until Oumuamua's arrival, the search for extraterrestrial life focused largely on detecting radio signals or finding planets with conditions similar to Earth's. But Oumuamua has shifted the paradigm. Now, scientists must consider the possibility that alien civilizations may not rely on radio waves, but may instead use physical probes dispatched across the galaxy to collect data and explore foreign star systems. If such civilizations exist, it's plausible that they might have different forms of technology that we can't conceive of yet. Probes like Oumuamua could be just one aspect of their exploration toolkit. This revelation would not only expand the scope of the search for extraterrestrial intelligence, SETI, but also raise the bar on the technology needed to detect and communicate with such entities. The potential discovery that Oumuamua might be alien in origin challenges humanity's place in the universe and forces us to reevaluate our understanding of life and intelligence beyond Earth. If advanced civilizations are sending probes across the galaxy, it suggests that we are part of a much larger cosmic community. It raises the philosophical question of whether we are prepared to encounter beings that may have existed long before humanity, with knowledge and technologies that dwarf our own. As Oumuamua hurtled through our solar system, our observational abilities fell short. The discovery of this object underscored a major gap in our readiness for observing interstellar visitors. While scientists could track its movement and detect its acceleration, they lacked the tools necessary to analyze it in detail. This has sparked a race to develop new technologies capable of intercepting and closely studying such objects. Astronomers have since been pushing for more advanced telescopes, like the upcoming Vera C. Rubin Observatory in Chile, which will feature an unparalleled field of view and scan the entire sky every few nights. With instruments like this, the scientific community hopes to identify interstellar objects like Oumuamua much earlier, enabling us to observe them as they enter the solar system rather than on their way out. Even more ambitious are proposals for actual spacecraft missions designed to intercept or closely observe interstellar objects. Imagine a spacecraft lying in wait at the outer edges of the solar system, ready to launch a close proximity investigation the moment an interstellar visitor crosses into its vicinity. Such a mission could provide unprecedented insights into these objects' structure, composition, and potential origin. The arrival of Oumuamua was a reminder that our solar system is not an isolated bubble. It exists within a galaxy teeming with objects, some of which will inevitably cross our path. Prior to this discovery, many scientists speculated about interstellar objects, but never anticipated witnessing one in real time. Now, a new scientific field has been born: the study of interstellar objects. This field blends astrophysics, planetary science, and even astrobiology as researchers seek to uncover whether these objects could harbor signs of life or technology. One fascinating line of inquiry involves isotopic analysis. If we could capture particles from an interstellar object, we could study their isotopic composition, potentially revealing clues about the object's origin. Different star systems have distinct elemental makeups, so analyzing an object's isotopes could tell us if it formed around a different star or even within a different galaxy. Then there's the question of their structural and compositional makeup. If Oumuamua was artificial, as Loeb and Musk propose, then we may need to rethink what qualifies as a natural space object. Could interstellar space be peppered with alien technology, drifting between star systems? And if so, might there be artifacts or remnants of these technologies waiting to be found? The prospect of advanced civilizations dispatching probes throughout the cosmos is both humbling and daunting. For centuries, humanity has viewed itself as the pinnacle of intelligence and capability, but Oumuamua's journey through our solar system forces us to confront the possibility that we are not the first, nor the most advanced explorers of space. If Musk and Loeb's theories prove true, and Oumuamua is a scout or probe, it changes our understanding of intelligence. Rather than seeing ourselves as unique, we would instead become part of a vast network of species, each observing, exploring, and perhaps even communicating across interstellar distances. This realization could reshape our goals as a species, from technological development and exploration to more fundamental questions about the nature of consciousness, survival, and the ethics of contact with other beings. This raises questions about the ethical considerations involved in searching for and potentially communicating with extraterrestrial civilizations. Should we attempt to contact alien technology, or remain silent to avoid detection? Some scientists argue that we should adopt a cautious approach, mindful of the risks of revealing our presence to unknown entities. After all, if Oumuamua is part of a network of probes, then the civilization that sent it may be far older and more powerful than we can imagine, with motives beyond our comprehension. The philosophical conundrum of contact beyond science and technology is that Oumuamua challenges us to grapple with deep philosophical questions about humanity's place in the cosmos. If it was sent by an advanced civilization, then we are part of a shared cosmic history, one in which species reach out across light years seeking connection or knowledge. But this reality brings as much unease as it does excitement. How should we interpret an object that may be observing us silently, collecting data on humanity, our planet, and our solar system? What happens if this is just the first of many encounters? Some philosophers argue that the discovery of alien technology would challenge the very fabric of human civilization. Religions, political ideologies, and cultural narratives often hinge on the assumption that humanity is unique, or even central to the universe. An encounter with an object like Oumuamua, if it indeed proves to be of alien origin, would force a profound re-examination of these beliefs. The recognition that we are observed, perhaps even catalogued, could shift our understanding of what it means to be human. If civilizations are sending probes to explore other star systems, it implies a certain level of ethical or scientific curiosity on their part. It suggests a universal drive to understand, connect, or perhaps even empathize with other life forms. But this leads to an unsettling question. What if we're not ready to meet these beings or understand their motives? Are we prepared to redefine humanity's role as one of many civilizations within a vast cosmic ecosystem? The future of the search for extraterrestrial intelligence, SETI, is now fundamentally altered. Before Oumuamua, much of the search for extraterrestrial life centered on listening for radio signals or discovering exoplanets within the habitable zones of other stars. But if advanced civilizations are instead dispatching physical probes, we may need to adopt a different approach. This could mean developing new kinds of detection systems specifically tailored to capture high-speed interstellar objects, analyze their materials, and track their paths with precision. With each new interstellar object that scientists discover, humanity will gain more opportunities to observe and possibly interact with alien technology. If Oumuamua was an alien probe, it might not be the last one to pass through our solar system, nor the most advanced. Advanced telescopes and detection technologies are already being designed to focus on such objects, expanding the possibilities for future encounters. The SETI community has already shifted its focus somewhat, exploring the possibility that alien civilizations might employ a wide range of communication methods. For example, some scientists now believe we should be looking for technosignatures, or the physical markers of advanced civilizations, rather than traditional radio signals. This includes things like laser pulses, megastructures around distant stars, or even engineered objects like Oumuamua. Preparing for the unknown, whether Oumuamua was a random rock or an alien probe, has left an indelible mark on humanity's quest to understand the universe. We are now left with a critical choice. Will we actively seek out these objects, preparing ourselves for encounters that might challenge everything we know? Or will we wait passively, letting these mysteries pass us by, too afraid of the answers they might reveal? Some scientists argue that we should view these interstellar objects as invitations to learn, to reach out, and to prepare for contact. Others caution that we may not yet be ready to face what these visitors could reveal. The true challenge may lie in finding a balance between curiosity and caution, exploration and restraint. Oumuamua's brief visit to our solar system in 2017 may have passed, but the questions it left behind continue to captivate scientists, space enthusiasts, and the general public alike. The object has challenged our understanding of space, forced us to confront the limits of our scientific knowledge, and opened up possibilities that were once confined to science fiction. As we prepare for the possibility of Oumuamua's return, we are on the edge of an incredible frontier, one that could redefine our understanding of life, intelligence, and the vast, mysterious universe we inhabit. Whether it was a natural object or an alien probe, Oumuamua has left an indelible mark on humanity's search for answers and inspired us to keep looking up, ready for whatever else the cosmos has to reveal.